All right, hi, thanks for coming along. So this is my part of the prototyping lectures. Now, a bit of a warning first. This is, well, not so much a warning, but this is the first time I've taught this course, and Mark's asked me to change a huge amount of it. So, which kind of gives us the unique opportunity in that if there's anything you guys don't understand or anything I need to explain further, anything you guys are interested in learning more about, or things that I'm talking about which you really don't care about, we can change it. So it's going to be more of a, I guess, an interactive, like what you guys are interested in and what skills and tools you guys need to know. I'm happy to include that. I do have a sort of rough plan of what to teach, but if there's anything, we're flexible enough so we can change it around. Right. Anyway, so just to recap over what Mark sort of said the goals of this course were. So he's kind of sort of done it a wee bit backwards, I guess. So his part was really part 2, to provide you with an understanding of the interaction design process. And my part is more to provide you with the skills to design and prototype interactive interfaces. So he's sort of given you a background of the theory and stuff like that, and now I'm going to dive down into some of the actual prototyping, with physical and software prototyping tools you can use. And again, as I said, we've got a rough outline of what we're going to be looking at, but this is flexible depending on what you guys want to do. So we're going to look at some software prototyping for the next few weeks, and then we'll do some hardware prototyping and systems prototyping, which will be things like 3D printing and stuff like that to bring an entire system together. Also, one other thing we can do, if you're interested, is Michael has volunteered last semester. They ran labs in conjunction with the lectures. Michael's volunteered to run the labs if you guys are interested in it. The labs also need updating, but he said he's happy to do that. So, you know, if that's something you guys are interested in, they're usually short, like an hour tops, and just gives you a bit of practice sort of working with the things we talked about. So, yeah. All right, so just before I jump into a programming refresher, can I just get a refresher of my own about what your guys' programming backgrounds are? So.
I learned a very little amount of C# in my first year in uni, and then after that I've done Java, basically.
Okay, so you'd say you're fairly confident, happy-ish with Java?
Yeah.
Okay.
But not hugely.
That's right. That's right. That's good. That's, yeah, means I've got something to actually teach you. Because if you're a pro, the next few weeks are going to be kind of boring for you. And
yeah, probably, I should say I did like a Java and C course in the first couple of years, although I did C# or with Unity.
okay.
It's not really much coding. Well, it's pretty basic coding.
Right. No, that's cool. That's good. Sweet. Right. That's actually what I was hoping for. So that way it's not all going to be boring rehash for you guys. All right, so we'll start off with a little bit of a programming refresher, and one thing which came up from the feedback from our slides is people wanted more in-class demos, so that's what I'm going to roll with, because I am a programmer more so than anything else. So what we'll do, I'm going to use Visual Studio 2010 for all the demos and stuff like that. You guys are welcome to use whatever you want. We've got licenses of Visual Studio 2010 that you're free to install on your personal computers and stuff like that.
Is that better than Eclipse or?
It's mainly, the reason I use it is because it is what I'm familiar with. Eclipse is pretty good. Some things I find a little bit clunky doing, but actually, sorry, I'll start this from the beginning so I can explain what I'm doing. But yeah, your Eclipse will certainly work, and you're welcome to do whatever you feel most comfortable with. But I can provide most support for Visual Studio, so if I can push you in that direction, that'd be good. Right. So anyway, Visual Studio, open it up. It's all good. So we go File, New. We want to start a new project, and you'll see I've set it to put it on the desktop because I don't really care because this is my laptop, and if it gets all messy I can just delete everything afterwards. So we're going to create an empty project. So you see there's a bunch of different types of projects we want to do here, but empty, I'm just whipping something up quickly so I don't really care. And that'll create a new project with a bunch of empty folders. So I'm going to create a new source, not going to click on that one. I'm going to create a new source file, and I'm just going to create a CPP file and call it main. And there we go. Now I have my file that I can write stuff in. So if I just throw that over, That's fairly legible. Right, so quick programming refresher. And this is just the real basics, just to refresh you guys. So you probably remember we have variables, hopefully. So let's just create a new main class. And so we have a bunch of different variables. So you see here we've got x equals 1 assigns 1 to x, 0.5 gets assigned to y, ch gets the character x, which depending on, like typically will be actually represented as an integer, but there's special data types, and I'll go into data types in a second, and str equals a string of hello world. So this is basically just assigning some information to these variables. And as I said, variables have types. So you did Visual Basic at some point in time, didn't you? You said someone did something. Anyway, there's certain languages and what's known as untyped, which means you can basically just go x equals 1, and it'll. Oh, okay, maybe that's what it was. But you don't actually have to say x is an int, x is whatever. It will just try and figure it out or put it into some sort of thing. I know Visual Basic, for example, which is, I'm going to use this example, even though apparently neither of you used it because it's the untyped language I'm most familiar with, has created a new data type called variant, which basically will just take anything, but it's enormous and it's incredibly slow to work with, but it allows you to do untyped things, whereas things like C, and Java and all those sorts of things are types, so you have to explicitly define what they are. So for example, if we want to assign 1 to x, and we know x is only ever going to contain whole numbers, we can define it as an integer. So x equals 1, and if we put a breakpoint there, so to put a breakpoint you can either click or push F9 or whatever, and then we'll go up to run, and yes, we do want to build it. So you'll see we've got this command window in the background, which isn't actually going to print anything because I didn't tell it to. But we can mouse over x. Now the program's just started running, we haven't signed anything to x, so it's just got some arbitrary garbage number in there. But if I step through, now I'm not sure which one, so I can't remember what the thing is because I use keyboard shortcuts all the time, but we can use step over F10 to basically execute that line of code and go to the next one. We'll see now x is 1, hooray. Super exciting. So we can keep on doing things like that. So we see now we have y is equal to 0.5. Now if we assign 0.5 to an integer, I'm guessing you guys can probably figure out what's going to happen. So an integer only contains whole numbers, so if we try and assign part of a number to it, it'll be 0, because in the case of C and stuff like that, it doesn't round, it just truncates, so it cuts off everything after the decimal place. So that's not really the behavior we want, so we'll say a float, which is a floating point number, so it's a number with things following the decimal place. Or we could use doubles, which allow us to have larger numbers, but I'm not going to go into too much detail about all that sort of stuff at the moment. So you see now we have x is 1 and y is 0.5, which is all good. So we have chars, which is a character, basically gets represented internally as a number, but the numbers can only go from 0 to 255 because it works with ASCII, and that's all that's been divvied up. We have strings. Now strings are a little bit more complicated in C because they're not actually a default data type, so we actually have to include the string library, which will allow us to use strings. And string is included as what's part of known as the C++ standard library. So if we want to access it, we need to say std, which is the standard library, string, and then we can create our string. So str equals hello world. And now if we run that, so x is 1, y is 0.5. String at the moment is a bad pointer because it's basically pointing to a piece of data. At this point we haven't set it to anything, so it's pointing off into nothingness. But after we assign it, you'll see we've got string equals hello world. Now these, you can actually do character arrays and stuff like that if you don't want to use strings, but strings have a bunch of useful properties that if you're familiar with Java you're probably used to. So you can do stuff like append, you can get a letter at a certain point, and all these other features which really use them all the time. So it's worth using the C strings rather than character arrays and stuff like that. So we have booleans as well, which is a simple yes or no, true or false. And in fact, we have false and true with all lowercase being keywords. So that's what we use. You can assign a 0 or a 1 to them, which will do the same thing, but It usually makes code slightly more readable if you use the ones you're supposed to use. And I've mentioned down here signed versus unsigned code, so probably not really something you need to worry about so much, but all numerical values in C are defined signed as default. So you can specify it, but basically that means the same thing. And what signed means, it means it can be negative as well. So I can go negative to some large number to positive some large number. If you know you're never going to be in negative and you need to get numbers which are larger than the largest size number it can hold, you can actually say unsigned, which will basically mean it goes from 0 up to twice what the signed integer can, but that's not particularly important unless you're dealing with numbers which are too big to fit into it. In which case, in a lot of cases, you might move to a larger data type. So instead of an integer, you might use long, which can hold something like 16 million or billion or something. Huge numbers anyway. Right, and I've also mentioned down here casting. So casting is, pretty sure it's in Java as well, but basically allows you to do things like, so let's just set this float to 1.5 now, and let's say we want to get the y whole. So y whole, we just want to get the whole part of this. We don't want to get any fractional parts. What we can do is we can actually take y, and while this will work as it is, because the compiler will figure out what you're trying to do is actually get the whole part of the float and put it in an int. What we can actually do is we can cast it by telling it what data type we want in brackets. And just run this again. You see y is 1.5, y whole is currently nothing, but afterwards it gets set to 1. So we've basically told the compiler we want to treat y as if it was an int. And you can do this for a lot of different data types, and most of the time, as long as you're using the standard data types, it'll figure out, which way it's supposed to be going and stuff like that. And we can do arrays as well. So I'm sure you guys are very familiar with arrays. So there's multiple ways to do them in C, but we'll start with the easiest way. So basically, oops, that's Java. So we basically say int x, and by putting these square brackets on, we define we want it to be an array. Now, there's, again, multiple ways of even doing this. So we could put it like that, which says we want x to be an array of 3 elements, starting at element 0, so 0, 1, and 2. Or if we already know, say we want an array and we already know what it's going to be, array. So we could do this, and we could go, let's make that a char. So we're going to make an array of characters. So you saw before I made a string with hello world. This time we can do the same thing with an array of characters. Whoops. And I'm not going to type out the whole thing because it's going to take me forever. But if we run that, you see hello world array currently points to some garbage in memory. But after we run that, you'll see it now the first element contains H, second one is E, L, L, O, and we can dereference that simply by going like that. For example, will give us actually the second element. So you see here, hello world array 1 is the value E, which has the integer value of 101.
That hello world array, initially after you'd already assigned hello to it, it still had garbage in the...
Yeah, so the way character arrays work in C is or if you're treating them as strings, they're supposed to be null delimited. So basically you set an extra value at the end to be 0. A little bit of luck, this will work. And it'll basically tell it that, like, it scans, like, when it's, for what it's worth, it's created an array with 5 elements in it. But if you're using the mouse over, or if you try and print that string as is, it won't know when the string is actually supposed to finish. So we have this special character, which is known as the null delimiter, which basically says when it hits that, that's actually the end of the piece of data we're working on. So we can use 0, or we can do what are known as escape characters, and /0 will do the same thing there.
Does that so does that mean it's not when you design an array and specify it that way, just a bracket with nothing in, and then how long does it make that array?
So if you just did like that, you mean?
Yeah.
So in that case, it wouldn't have a size at this point in time until you actually did something with it. So this is in, like, the arrays in C places. It's where it first starts getting kind of dangerous, and this is where earlier code where a lot of memory leaks and possible hacking exploits would come in, because people realized if you wrote past the end of the array, you could actually start overwriting code and stuff like that. So I'm showing it as an example here. I'd urge you to maybe try and avoid using arrays and stuff and see where possible. And in fact, as I was talking about before, the standard library provides things like vectors, which is a lot more like your Java sort of thing. So you have a standard vector, and you can go v dot, I'm not getting any IntelliSense, which is awesome, but you can do things like v dot push. Oh, that's because, so it gets a little bit, so we have a standard vector. I need to tell it what kind of data I want it to hold, so an int, and then I can go v dot push back, and I can push ints onto it. So it's getting a little bit more complicated, and if you guys are interested, I can go over some of the standard library data types later on, but using vectors is safer because you can do things like v.size will tell you how many items are in an array. There isn't actually any safe way of getting the size of an array in C. If it's not null delimited or whatever, you never know quite how big you're going to get. But yeah, anyway, so we'll move on from there. So that was obviously a basic thing about variables. Operators are all pretty simple as well. So if we have int x equals 1, and we go x equals x plus 1, we run this now. Hopefully you guys can figure out what's going to happen. So we set x to 1, and we go x equals x plus 1, so x is now 2. Pretty straightforward. And this works for all the mathematical delimiters, plus, minus. This is divide, this is multiply. This is to the power of, which in C only works for integer powers. You can do things to the power of using the power function. So again, lots of little things to learn, but if you guys are interested, we can go over those later. And this is modulo. So basically, modulo divides two numbers and takes the remainder. So if we go 9 modulo 2, so basically this is the equivalent of divide 9 by 2 and then tell me what the remainder is. So because 9 divides into 2 with a remainder of 1, the answer is 1. If that was an even number, it would be 0. Comparison. So this is one thing I still occasionally get wrong, especially in if statements. So if we want to check the value of x, we need to do that. X double equal 1. This will actually assign the value of 1 to x and then return true, which sometimes really screws you up because you totally cannot figure out what you've actually done. So yeah, that means, are these two things equal? If you use the exclamation mark, it means they're not, make sure they're not equal, less than, more than, less than or equal to, greater than or equal to, and the last two there are and. So if x equals 1 and y equals 2, so both of these have to be true, or this is the or. So if x is true or y is, if x is 1 or y is 2, then do this. C has a few additional assignment things, although Java has all of these as well. So we can go int x equals 0 if we do, so here's obviously the first one, we just assign the value. We can do plus equals 1, so that will add 1 to whatever's in x. That will subtract 1 from whatever's in x, multiply 1 to whatever's in x, and when we're doing these, we're actually assigning them back as well. And obviously the plus, plus, minus, minus, just increment it or decrement it by 1. We have some control statements. So I've already sort of run over if. So if x equals, x equals 1, print if x is 1. We'll check to see if x is 1, and if so, it'll print out x is 1. It's complaining because I've actually set x to created a variable called x. Else we can do if this, print if x is not 1, which basically says if this is true, run this. Otherwise, if this first statement isn't true, run whatever's in the else statement. And of course, we have else if as well, where we can do another comparison. So x is 2. So if the first case happens, it'll run this. If the second case happens, it'll run that. And otherwise, if neither of these work, it'll run the last case. You guys need to see a demo of that running, or you're happy just to take my word? All right.
John's watching.
Sure. So as I said, it's pretty basic. I'm sure he'll be fine. I'll start on the next one anyway. So then we have for loops. So in I equals. So I'm pretty sure this is the same way they work in Java. It's been a while since I've done anything, but yeah. So you basically specify your starting condition. So I is 0. Your ending condition, or your looping condition. So keep looping as long as I is less than 10. And your iterative condition. So in each case, we're going to add 1 to I, and shouldn't be particularly surprising if we print out the value of I here. Oops. Yeah, right. Actually, this is something he could probably benefit from. So the command window will automatically disappear in Visual Studio 2010 by default, which is kind of a pain. What you can do is you can open up the properties, go into linker, system, and change subsystem to console, which in all versions prior, it used to be by default. And then so now that you're back, I'll just quickly run over this again. So the console window for Visual Studio will disappear straight away by default, which isn't particularly useful if you're trying to debug something. What you can do is if you open the project, and you go into linker, and then you go into system, and you set subsystem to console. So normally it's just not set by default. And then we go debug, and if we start with debugging, we're going to get the same problem. But if we go debug, start without debugging, you'll see it actually leaves the console window open, so we can actually see stuff. But of course, that'll stay open as long as the program's running. So if we're stepping through it, we can sit there and watch it, put all the bits in, which is fine. But that's a little thing that I didn't realize because I've been using an older version of Visual Studio where it left it up by default, which is fine. So yeah, it's a for loop. Obviously, you can fill out as many or as few of these as you want. So I could quite happily just do in I equals 0 down here, take that one out, and the loop will run exactly the same as it just did. And in fact, you can remove that one and then put that down there, and I'll do the same thing. And if you really want to just completely waste a for loop, you can even do something like this. If I equals 10, break. So break, I mentioned down here, basically breaks out of the loop. So I don't delete that one. So now I have a completely empty for loop, which is kind of pointless. But just to show that you can do it, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll close. So that's all good. And the only other thing just to show on there is while loops, which is pretty straightforward as well. And I equals 0, while I is less than 10. Print F.
Means new line. What does the?
Right. Yep. So I actually wasn't going to use the printf. So printf is a C throwback, and basically the way it works, a lot of people don't use it these days, and admittedly I should probably stop using it, but I'm so familiar with it. So basically what you do is printf means print formatted, and in here you can define the format. So you can just put hello world, and that'll print hello world. But then you have a bunch of these escape characters. So if you want to use an integer, use D, because integer starts with a D. The D's silent. Yeah, I don't know why it's D. I'm sure there's a good reason for it. If you want to write a character, you can use C. If you want to write a floating point number, use F and all that sort of stuff. A better way of doing it, and what I tried to remind myself to do, is, again, in the C++ standard library, we have this thing called cout. Oh, what the hell's going on? So we can go standard cout, and this will do the same thing, but it automatically identifies what sort of data type it is and will print it, like format it and print it correctly. It's got a weird syntax of doing. Oh, okay, so it helps if I actually do something with I. It's got a weird syntax. Basically, you're sort of pushing data into it, which is one of the reasons why I don't use it that often, because it looks kind of weird. So it's up to you which one you choose to do. This one's probably more powerful but I find printf sort of, it's easier. Once you know what the escape characters actually do, it's actually kind of easier to read, in my opinion, but I'm sure a lot of C++ people would hang me for that. Anyway, so this is a while loop. It's pretty much doing the same thing as we were doing before, except we only have the one condition, the terminating condition. And so we have this continue thing as well. So what we can do is we can go if I modulo 2 equals 0, continue. And what continue, actually I need to put that up there. What continue does is it basically skips everything else which is in the loop and just goes back to the start. So with a little bit of luck, if I've done this right, it'll print out numbers which are odd because it comes through and it checks to see if it's an even number, it just continues, so it goes back up here. If it's not an even number, it'll print it out. So I don't know that I've ever actually used a continue statement, but it's nice to know they're there. Right, and now just on to the last one. So we're sort of taking...
So do you have other cases?
Yes, right. Yep, so we can do cases, which, good one. I probably should have put them in there. So in C, we have what's known as switch. So say we have someone's age. We want to switch age. And then we go case 1. We say printf, you are 1 year old. Put a new line in there. Now there's an interesting thing about cases in C, is that they, and then we have a default as well, which basically says whatever didn't get caught will get caught here. Now there is an interesting case in C. I can't remember if this is the same in Java or other languages, but right, so you can see there age is 0 and didn't catch 1, didn't catch 2, so it printed you are not 1 or 2 years old. However, if we go this one, you'll see it says you are 1 year old, you are 2 year old, you are not 1 or 2 years old. So we have to use that break statement that we saw before to basically say once you finish processing here, stop. Otherwise, it'll catch at the first statement and then it'll just keep on running through all the other statements, which can be kind of useful if you have like a hierarchical sort of thing. So, you know, if you've got, say, if we work from the bottom up, if you've got this case, do this part. If you've got this case and this case, you put the second case up there and it'll execute both too, and you can do all the way up. But again, to be honest, more times than not, it's actually more problematic than it is actually useful. So if you're using cases, just remember to throw the break in there. Otherwise, it'll start doing stuff that you're not expecting. Right, so now to do some things which are actually useful. So functions. So say we want to do something which prints out someone's age. So we want a print age function and put 1 or yeah, something like that. So we basically define a function and we start with the return type. So void basically means we don't return anything. Then we have the name of it, print age, and then, actually hold on. I'm sure you guys can pick up. And then we have any arguments which we might have in here. So printf d years old. Oh, right. Helps if I actually tell it what number to print. Otherwise, it's just going to grab something out of memory and put it in there. So 1 year old. So originally I was actually going to start with no arguments, but you can see you can add arguments and you can put in as many as you want. And they can be any data types you want, anything like that, and that's all fine and good. As far as return values go, so let's do another one. Float calc GST. So this is, for those not from around here, this is the goods and services tax.
We had in Australia first.
You call it something else though, don't you?
GST.
I thought there was another.
Get rid of it.
Oh, I thought Australia had another name for it. And if we go print cost, including GST in, and we can actually just basically call the function in here and print its return value out straight away. which is useful. So GST in New Zealand, I think these days is 15%. Oops, 1.15. So the cost of a $5.99 item, including GST, is apparently $6.88. You're gonna have to take my word for it. I'm gonna take the computer's word for it because I'm not gonna bother figuring it out. But yeah, so we can do stuff like that, which again should all be fairly straightforward. Obviously, you can do things like overloading as well. So say we want to be able to. So if I try and pass in or call calc GST, in fact, this will probably work. So it's not the greatest example. Oops. Small keyboards, big fingers. So this will probably work just fine. Yeah, which is unfortunate, but in the odd case, in the chance that this didn't work, for example, what we can do is we can actually override it and say, okay, we want to have the same function calc GST, but this time instead of taking a floating number, we'll take an integer, and then we could do something like casting, as you saw before, float cost times 1.15, and put the bracket in. Oops. And that's all good. And just to show you that it does actually make a difference, float. And assuming I've done this correctly, we should see now. So this is calling the function which takes an integer, and whoops. This one's not working. Oh, right, okay. So that's actually not enough to tell C that it's supposed to be a float, so you have to put a little F at the end, because otherwise it could be anything. And this one's calling the floating one. And the one last thing I'll do, just because we're going to come across it soonish, is we can actually have optional arguments as well. So if we just jump back to this, actually we'll do another calc GS, and we'll modify this one actually. So now we have this GST percent thing here, which if I leave this like this, it will complain. If I try and build it, no, it won't, because it's going to run the int version. So it'll complain when I try and build this one that, where are we? Calc GST function does not take one argument, it takes two. One's the cost and the other's the GST. What we can do instead though is we can make that an optional argument and go 1.15f, and that will say by default it'll set GST to 1.15. Otherwise, if I want, I can actually specify that GST is now at, I guess, 100%, and it'll do that just fine. So again, all fairly straightforward stuff. And what we'll do is we'll just go through very quickly classes and objects. So we've looked at functions now. The idea behind classes and objects is we are encapsulating data. So we can say, well, let's have a new class. Probably need to give it a name. Give me a good example of a class. Well, it doesn't really tell us what we're doing. So this is probably a pretty poor example of a class name. But okay, so we can have a class. Classes can have constructors. What's that? Deck. All right.
DCK or cards, whatever.
Yeah. So we can have initializers, we can have destructors, and let's just say void print top card. Right, so in C, everything, I can't remember off the top of my head what it is. I think it's private, so we need to define these as public because we want these to be public functions. And down here we say these are private, so int top card. And actually we'll fill, so this is a class prototype, so then down here we could go like deck, and put in the code down here, or because this is just a small class, I'm just going to do it up here. So int top card equals 5. So this is a card which has no suits, it just has numbered cards. And oops, don't want to do that And then here in the destructor, any data you'd allocated or whatever you'd clean up. In this case, we'll just set top card to negative or to 0. Not that we need to in this case. And here, printf top card. Top card. Right, this is obviously an incredibly simple example because I don't want to spend too much time on this. So now we can create a new deck D, and we can go d.printTopCard. And look, the top card's 5, magic. Right, so yeah, as I said, you can assign, so this obviously is a method which is private to deck, so we can't just go print top card, we have to actually call it on an object. So it has some properties as well, so in this case it has this top card, but I've set it to private, so if I try and do d.topCard, you see it's there in Visual Studio, but it's got like a little lock on there which says that I can't access it, so if I try, compiler's going to complain. And public and private as well. There are other ones you can use like friend, but you know, again, it's not very common. Oh, you can use the only other one you can, which is probably worth using, is protected. And protected just means that classes which inherited off it can access those, but you can't access them outside of the class. How familiar are you guys with inheritance? Okay, I'm not going to do a huge example because I don't have one prepared and they're quite difficult to think of off the top of your head. But say, you wanted a specialized deck of cards which maybe only had values between 0 and 10. You could then go class deck smaller or something, and you would say that inherits off deck. And then you'd go deck smaller, and so you'd put in all the same functions and stuff like that, but this time you'd make sure that the card values were within the top thing, and any public or protected methods or data which are in deck smaller can use. In this case, deck smaller wouldn't actually be able to access top card because it's private, which means it's private solely for deck. Right, any questions about that? No? All right. If you guys want, I can, next week we can throw in some, or on Friday rather, we can throw in some better examples, but I'll just quickly go into scope as well. So scope's the last thing I wanted to briefly touch on.
Static as well.
Yeah, so static isn't actually it doesn't define whether it's public, private, or whatever. Static basically means that the variable, well, no, it can be changed, but it will retain its value even after it goes out of scope, which is actually what we're getting into now. So it's probably a good time to bring that up. So we have basically the scope defines how long a variable will live. So if I have, say, a variable called x up here, and I say x down here equals 0, inc x here, and then printf d x. So basically we have this one x thing, because it's up here in the scope, it'll exist for all of these. So we set it to 0 here, we increment it here, and here it gets increased by 1, and then we print it out. So we're always using the same copy of x. If I now change this one to down here, we're going to get a complaint because it says, well, actually, I'm not really sure what x this is referring to anymore, and so on and so forth. And same thing if we do an x up here, down here, it'll be like, okay, I don't actually know. So now this will just come out as, okay. So this time, this time we'll just get 0 because we've got a 0 down here and then we increment it, but we're actually only incrementing the x in the scope up here. So it starts to get a little bit confusing, but you just have to be wary of when you're programming what scope each variable's in. And what you were saying about static before, so if I keep on incrementing x here, it's always going to be 0 because basically every time it comes into this function, it creates a new copy of x, adds 1 to it, and then returns. But it's actually, if I move this one into here, you might think perhaps this would x would keep incrementing, but what's happening is we go up here, we add 1 to x, print it out, and as soon as we exit this function, that x gets destroyed, and then it gets reset to 0 as we start again. So what you're saying about static is if I say that's static, basically I'm saying don't destroy this copy of x. So the first time it enters the function, it realizes that x hasn't been created, creates it, sets it to 0, adds 1 to it, and then when we exit this function, this x actually still hangs around. So next time we come in here, it's like, oh, x still exists, so I'm not going to reset it, so we add 1 to it. So you see now it's gradually incrementing over time. Right, so that was a very quick refresher. Hopefully you guys got something out of it, even if just sort of an idea of how C compares to Java. Because now we're going to jump into processing. So processing is, last semester they sort of taught processing and open frameworks side by side, but the complaint was that it was too much to absorb all of it in such a short time. So Mark has actually asked me just to focus on open frameworks this time around, which is why all those demos were geared towards C, because open frameworks runs on C, processing runs on Java. If you guys are interested, the original labs, or the labs from last semester, were done in processing. So if you guys are interested in learning more about it, I can ask Michael to use those labs, and maybe you can sort of compare the two, processing and C. But basically, I've stolen these slides, or in fact, Mark stole these slides off this guy, Mark and Ignac, sketching and code processing. If you search for it, you'll be able to find it all. But to be honest, like, it's just the slides which are available, and they're sort of pretty high level. So I'd imagine when he gave his talk, it probably got into more detail. But yeah, so basically processing is an open source, cross-platform, multimedia programming language. And it was designed with the idea of basically making programming easy for artists and people who aren't programmers. So it basically takes out a lot of the complicated stuff and just makes it easy to sort of start doing stuff. And it's really popular. It's picked up a lot of steam it's come out in 2001, but I think probably like maybe in the last 5 years or so, it changed hands and then sort of became an open source community thing, and it's become really popular. So this is basically what processing looks like. It comes with its own little IDE, although you can use other IDEs, which is fine. And you can just basically start pounding commands in there, and it'll start doing stuff. So are either of you guys familiar with Python?
Vaguely-ish, not
Okay. So, you remember from Java how you had before you first started programming, you have to be like public static void main, blah, 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 and do all that sort of stuff. One of the reasons Python sort of got popular was because you can just start typing code out. You don't have to worry about, like, Java forced people into using OO, which isn't really that useful if you're a beginning programmer. You sort of just want to learn how statements and stuff work. Java sort of forces you into OO, which makes the learning curve really steep to start with, and then it gets smoother. Python, you don't have to do that. Python, you can just start typing stuff in, and it'll run. It doesn't care if things are in classes or objects or whatever. Processing actually does the same thing. It runs on top of Java, but it actually hides all of the Java stuff, so your public static void main and stuff like that. So you can see here in this example, they've just basically started typing commands out and being able to create this. So what we can do is we can actually run that. Oh, actually, I was going to say, so processing, if you want to get a copy, go to processing.org, go to download. If you search on Google processing, it's like, or processing language, it's like the first one. And you can download versions for Windows, Linux, and Mac. This laptop seems to be a little bit flaky with its internet connection, so I did that earlier, and I actually unzipped it as well. But I can assure you this is the version straight off the website with no modifications. So basically, you unzip it and you just get all the stuff. So if we just double-click on processing, it's like, yay, processing. So we get this, and as you can see, this is very similar to the IDE we saw before, except he's got a lovely wood-paneled background. But now I can't read it. Right, so I will try and copy these guys' code as best I can. So size basically defines the size of the window, which pops up. So 512 by 512. You get a 512 by 512 window, very exciting. Then we can go background, which basically allows us to set the, if I can spell it right, set the color of the background. So 255 is white. As far as I'm aware, it's only in grayscale. Well, I'm sure there's probably ways to set it non-grayscale, but I think it just starts with grayscale if you just provide one number. Then we can define our fill color, so 255, 2550, which for those of you who are very familiar with your RGB is yellow. And we can create a new rect. And so if you actually go into help reference, you find it's got a really good reference menu with all the functions which you can use by default. But basically the format for rect is we provide the X and Y coordinates and then the width and height. So if we run that, we get a yellow square. Pretty awesome. And then we do the same thing. So this is 255 red 00, so it's going to be red. And we'll do, I believe that says ellipse, and hopefully I've spelled that right, at the same position and same width and height, except for the rectangle, it treats the X and Y position as the upper left coordinate, and with the ellipse, it treats it as the corner of the circle, or the center of the circle, and then it's width and height. So I think it basically creates a bounding box. So it's creating an ellipse with diameter. Well, it's creating a circle in this case because these are equal, but it's effectively a circle with a diameter or radius of 75. But yeah, so you can see it's really easy just to get in there and start punching stuff in and actually get a feel to play around with it without having to worry about all the OO stuff and stuff like that.
Can you make good programs with it?
Yeah, we're getting there. So. Oh, okay, so this is the last slide, except the text is a lot easier to read, so that would have been a better one to start with. So this is another one. In fact, this is kind of cool. I'll try and quickly type this out. Okay, so the processing IDE is missing a lot of shortcuts which you might be useful, like being able to select all text, which is kind of a pain, but that's okay. So this one shows some of processing's internal functions which you can modify. So processing provides this setup function which basically runs when the code first gets run. So it's internally behind the scenes you have a public static void main and it calls setup. So you can stick your code in setup. If you don't do anything, it just doesn't do anything. And it also has a draw function. You can tell they're special functions because they go bold. And draw basically gets called every time the frame gets drawn. And ellipse, whoops, mouse X, mouse Y, Y, yes. And we have void mouse moved, which gets called, not surprisingly, whenever the mouse moves over the window. So it's sort of hiding a lot of this function that you'd normally have to do by yourself and making it quite easy. So this is kind of cool. It basically just, if you look at the code, it's fairly straightforward, but basically what it's doing is every time the mouse moves, it's calculating the sine of a number which is constantly increasing, and of course the sine wave goes like that, so you notice that as it'll get smaller and then it'll get larger in a sine wave form. So it's you know, kind of a neat little visualization-y sort of thing, but you're written it in essentially 5 lines of code plus some function prototypes and stuff like that, or function definitions. And then you can get on to more complicated things. So obviously, because it's sitting on top of Java, it supports all of the Java functionality. So you can do classes and all that sort of stuff as well. So this one actually only has a snippet of the code, so I can't run this one. But this is a particle generator, and you can see they have life and stuff like that, and life gradually gets decremented. So the idea is particles shoot out, and then they do some stuff, and then gradually they disappear. And you don't have, as I said, the processing IDE is very simple. Not always great, so you can actually run it in Eclipse and stuff like that. Although one thing I will quickly show you, and hopefully this works because I've had problems with it before, with processing is, so you can hit run and stop and all that sort of stuff normally, but you can also do export application, which is kind of cool. So save this, and it basically says export to application creates double clickable standalone applications for selected platforms. So you basically say what platforms you want this to run on: Windows, Mac OS, Linux, and you hit export, and if it works, awesome. So now we have a 32-bit Linux application, 64-bit Linux application, Mac OS application, and Windows applications. So I can run these, and now I'm good to go. So it's basically done the whole compiling thing, but it's kind of neat because it's actually cross-compiled it into a bunch of different things, and there's all the Java libraries and stuff that it needs to be able to do there. So you can just basically send someone this folder, and they can start using their, as long as they've got the Java. I assume you need the Java runtime. I haven't actually checked that, but as long as you've got that in there, they can run your thing, whether they're on Linux, Windows, or Mac OS. So that's actually really quite cool.
Is the processing smart enough to trim out what's not required, or
From the
Java library, or is it just...
I would guess probably not, considering it's throwing in some 4 megabyte things for stuff which I'm probably not using. But yeah, I'd say it'll do it library-wise, but I don't think the libraries that, like, if it's not using anything in a certain library, it won't include that library, but it won't carve down the library. So the executables are probably going to be bigger than things like C executables and stuff that you might create otherwise, because the compiler is just a little bit more naive. But yeah, so you can use it, as I was saying, you can use it in Eclipse and stuff like that if you prefer a better editor, because processing is not great for handling large projects. So processing is a language of interaction. It was designed to help people quickly build stuff. So you can do things like dealing with physical manipulation. So you can run it in conjunction with Arduinos and stuff, which we'll look at later on, which are basically little hardware platforms that you stick stuff into and you can easily prototype. Can easily deal with mouse manipulation. There's all these sorts of libraries for haptic interfaces, multi-touch, gesture, voice, and speech. It's an open source community, so everyone helps everyone else out, and it's quite nice. It's not like it's just some company which provides the documentation that they see fit, and you miss out on. And one thing which is quite good about processing in particular, it has heaps of libraries. So because like most open source projects, if you're interested in doing something, you go out and someone's already written the library to do it. So if you're interested in doing computer vision, you don't have to worry about writing computer vision algorithms and stuff like that yourself. You can just go out and someone's already written a computer vision algorithm. You can stick in there and hopefully it's simple enough. I've done a little bit of stuff with Arduino and through processing, and you can buy these random components. So I got like a 16 segment LED type thing, like you have in clock displays, like the old clock displays with the 7 segment ones, and it basically had 4 wires. I plugged that in and someone had written a processing library, so I could just basically go print this and it would print out there. So somebody had already written that. I got a little old Nokia LCD screen, again just pushed it into the Arduino. Someone had written a processing library and I could basically just say put pixels at this or load in this image and display it. So someone had done all the hard work of interfacing with all these pieces of hardware, so I could actually just do what I wanted to do, which I thought was really cool. Yeah, so adding functionality by importing libraries. So their jar files runs on Java. So they've got things like OpenGL, some popular libraries. We have Minim, which is an audio library, OCD, which does 3D camera stuff, I guess. Physics, which is Physics Engine, Bluetooth Desktop, which allows you to network with Bluetooth devices and all that sort of stuff. It's cross-platform, so because it's Java, it runs on Linux, Mac, mobile, and PC. Mobile being mobile phones, which support Java, obviously. There's an example of it running on the Android simulator. Theoretically, it will run on the Android phone without too much trouble as well. Yeah, so it comes with its own IDE, and I'm not sure what GUI it's using underlying. Something Java, so maybe Java Swing, SwingX.
Can create some buttons.
Yep. So you can create buttons, and there's heaps of GUI libraries and stuff out there as well. So if there's a particular style you want, you find someone who's written a library which creates GUIs in that style for you. Right, so that was a very quick introduction to processing because Mark wants us to focus on open frameworks. But if you guys are interested, Michael is a good person to talk to because he did the course. And in fact, I guess you would have done a fair bit of processing. Yeah, so talk to any of the other master's students. They've done a lot. And to be honest, they'll be far more familiar with processing than I'm sure I am. But we can do some labs. And if you guys are interested, I can throw some more processing stuff into later lectures as well. But in the remaining few minutes, I'll just give a quick introduction to open frameworks, and we'll have to go on from there. So open frameworks is basically, it is kind of to C++ what processing is to Java. So it encapsulates a bunch of functionality and libraries and stuff to make developing stuff in C++ a lot less tedious. You still have to program in C++, which if you're not very good at it is a shame. But it provides like hundreds or thousands of libraries in a normal sort of interface and stuff like that. So yeah, it's written in C++. You have to provide your own IDE for development. It doesn't actually come with one. So you can run it in Xcode if you're on Mac, Visual Studio if you're on Windows. You can use code blocks, which I'm pretty sure is multi-platform, and runs on Mac, Windows, Linux, etc., etc. So Open Frameworks basically sort of provides a gel which sticks a whole bunch of different areas together. So you can use it for media, and in fact, I might just jump out here to the Open Frameworks thing. This is the Open Framework, actually. This is the Open Frameworks homepage. I don't have Flash Player installed, so you can't see the demos they have there, but that's fine. But it basically gives a bunch of information, stuff like that, and you can go in and download it for OS X, Linux, Windows, iOS, and Android. So it actually functions on iOS and Android, which is nice as well. And you can download it, and for example, if you download the Windows build, which again I did a couple of days ago and just unzipped it, basically you just get this and you can just start working with it. So if you want to create a new project, just jump into the project generator and you do some few things. You give it a name, you tell it where you want to put it, what platforms you want it to run on, and whether you want to include any of these add-ons, and then you hit generate project and it will create a project for you that you can just start building on, but we'll get back to that in a minute. So it's sort of, again, it's quite nice. It's all encapsulated in there. So what I was saying before, the main idea of Open Frameworks is it sort of provides support for a whole bunch of libraries, which is good and bad. It makes life getting things set up a lot easier. So most of my research is done using computer vision sort of stuff, and I use OpenCV a lot. OpenCV can be an absolute pain to get working depending on what you're doing with it. Here you can just go, so these are the OFX add-ons, so you'll see there's heaps and heaps and heaps and heaps of them. So say I want to do computer vision, it's got its own category for computer vision, so it's got things for the AI toolkit and all that sort of stuff. But somewhere down here, it's got OFX, OpenCV. When you download that, it will work with OFX. You don't have to worry about building anything. You don't have to worry about trying to get the right libraries and all that sort of stuff. Basically download that, and then when you run your, what was it called? The project generator, you just say, I want to use OpenCV, and it will put in everything you need to do. And all the common functions are like rewritten to hide a lot of the messy details. So it makes life getting a lot easier. It's not as powerful, obviously, as using the libraries by yourself, but it's designed as a sort of stepping stone. And the good thing about it being in C++ and stuff like that is if you find that you need to use functions which people haven't encapsulated in their libraries, you can then just throw that out and actually link into the existing or the original library, and it's all fine. So that's really cool in that respect. There are some problems with it, obviously. If you want to use the OpenCV, you have your choice between Liquid ZYM's OpenCV 2.4, is OpenCV 2.4.1, is OpenCV 2.4.3, 2.4.1, and there's several other ones in here. So it can be a sort of a little bit confusing about, which library should you really be using, because it all depends on how much work these people have actually put into porting them. And in fact, if you look through here, there's people they've just taken chunks of OpenCV out, which is interesting to them. So, right, so this one, OFX Contour Util, takes a subset of features from OpenCV. So if you only want to do contour-based stuff, you might use this because it nicely encapsulates that, but then you're missing out on the other OpenCV functionality. So it sort of becomes a bit of a, you need to do your research on what libraries you're going to use and stuff like that. And I might just do a couple more slides and then we'll stop there for the day. So why use it instead of processing? Well, it's pretty debatable, but because it's running in C, theoretically it should run faster than stuff running in Java. You have accessibility of low-level information, so because it's in C, you can do a whole bunch of stuff which can be equally good and bad. You can do a lot of cool stuff with pointers and stuff, but you can also equally screw everything up and make yourself very miserable. So it allows you to use the debugger. Does the processing IDE provide any sort of debugging features, like breakpoints or no? So because you can run processing in Eclipse, which will provide you debugging things. but you can use the Visual Studio debuggers and all that sort of stuff using open frameworks. It's C++ and all the joys and pains which come with that, and it's Open Frameworks itself is all under version control, so all the libraries and stuff like that are on GitHub, so you can get them and make sure you've got the latest versions, and if you don't, you can easily update them and all that sort of stuff. So these are some pros and cons, which take with a grain of salt. This is one of Mark's slides. So it's easy to use, it's open source, and it supports interactivity. Cons are experimental and not complete. I'd also add in there sometimes the libraries. As I said before, you have no idea what you're getting when you get the libraries and other stuff like that. But anyway, we'll stop there, and on Friday we'll have a bit more of a look into open frameworks. So is there any questions? I know that was probably a fair amount of stuff to go through in an hour, but hopefully it's...
Is open framework, is it more, sorry, are the community contributions better in open frameworks than processing, or?
Yeah, I think you'll probably, being that it's a community-based thing.
Probably, like, if you have no experience in programming, then processing is super awesome, and you can start programming right away. And you can do pretty cool stuff very quickly. If you want to go a bit more advanced in C++, so frameworks just has more.
Yeah, so it's power over ease of use. As far as the community stuff goes, I'd say it very much depends on, like, I'd say both of them, the core of it, like the processing core and the open frameworks core, are probably, on par. As far as when you get into libraries, it really depends on who's written them.
So, say for the Arduino,
Yep.
It's probably better for the Arduino coding.
So I've only done Arduino coding and processing, and that was incredibly easy. I wouldn't be surprised if it's that much harder with open frameworks.
Since Arduino actually runs on C.
It's easier, is it?
Well, it runs on C, so the Arduino IDE
Yeah.
is just the C input.
But it's in the same style, same IDE as processing, isn't it? Like very similar looking. Yeah. Yeah. So if you're doing like Arduino coding, like the code you actually upload to the Arduino, they've basically used the processing IDE. So if you're familiar with the IDE, it's really easy. But yeah, as Timo said, like the actual code is in C. So, but it's in C rather than C++. So it's probably not that far off a lot of the Java stuff anyway. Did you have a question, Jihad, or?
Yeah, I say why one, for example, would use like all these kind of it's not really because it's experimenting, it's not complete. For example, think about someone it's maybe not one project. Most of the graduate students will build upon the project for quite some time. And the issue, why not kind of like to build upon, for example, latency and continue.
Yeah, I mean that's.
Instead of going like over this pain, and sometimes when you have something which is not working, and you are not really, if it's going to be maybe some prototype that you'll do for a quick project for maybe 2 months, for example, I would say I will go for this. But if I'm building something for research for 2 years or more, like something, I'd rather go for like the original libraries because I know where is like if I like hit like some kind of holes, I know how to really.
Yeah. Yeah, absolutely. These are prototyping tools. So in fact, the very first slide, it's prototyping interactive technology. So what we're looking at here is things which basically allow you to very quickly prototype something up. So instead of spending ages getting familiar with OpenCV and stuff like that, you can just use the stuff that other people have built on to build something in a week or a month, sort of thing. And that's what I said, like once you find you're sort of hitting brick walls, the idea is because they're building on these existing libraries, you can then go back to the existing libraries and you'll be fine. But even with, for example, OpenCV, that's still an open source community project. And I found that when I started my PhD, I had to write ridiculous amounts of code. I can pretty much redo my entire PhD project in probably about 2 weeks now, because all that code is now in the OpenCV thing. So it's OpenCV is obviously a lot more mature now. Like when I started using it, was 0.98 beta, so there was a lot of missing functionality. But yeah, it's if you're doing something long term, definitely, it's time to start looking at moving beyond the prototyping phase into actually becoming familiar with the libraries and stuff like that.
These libraries become quite mature and easy to use. Like it's not really like libraries which was 10 years ago.
Yeah, absolutely. Even OpenCV has become a lot easier, but I mean, there's still a lot of problems. Like I am helping out in computer science, running their OpenCV lab, and even then, we have had 2 help sessions now trying to get people just to install OpenCV on their machines, because they have all sorts of weird setups and stuff like that. Whereas Open Frameworks, because it's a limited subset of the functionality and it's all linked in, like you download it and it just works. Yes, you're probably missing out on some of the maybe interesting stuff you can do, but you can download it, you can install it, and it works. You're not spending 2 weeks trying to figure out why it's not working with your particular setup of Xcode 4.1, 5.1, because for some reason it's been putting the libraries in /opt/local/lib instead of where it's supposed to be, and all these sorts of weird things. Yeah.
It's one of the things which is like when students kind of know how to resolve these things. I'm talking about computer science. I think it's maybe rather keen, kind of like this level, that level. And
Oh yeah, absolutely.
And if you give them everything ready, the moment they will, at some point they will hit these kind of issues. And they, instead of kind of like, wow, what's what I should do now? They will maybe say, yeah, I have.
Yeah. No, I totally agree with you. I mean, it's tough love, really. You sort of throw them in the deep end and say you figure out how to do that. Next time you come up against that problem, you'll know how to resolve it. But in this case, we're just looking at how we can quickly throw prototypes together. So, all right. So yeah, if you guys have any feedback, if there's anything I went over, as I said, I know it was a lot to go over in an hour. If there's anything you guys want more information on, want me to go over, feel free to let me know. Send me an email. Come and swing by my office, and I can move some slides around and just cover the stuff that you guys are interested in. Otherwise, thanks.
Thank you.